Hi friends, for those of you who have already seen my first video on the evolution of industrial automation in the US, I would now like to follow that up with the second part of my talk with Mr. Lee Pryor. Lee Pryor, as I had mentioned, is a veteran of automation in the US, having been connected with the automation industry since the early 70s and has been involved in a number of projects that has gone through in the country. Uh, in this episode, he would talk more from the point of view of from the time the PLC started, then how the Ethernet came, and how it all moved towards process industries and the evolution of the automation into other industries and the implementation that happened thereafter. Uh, I will follow this up with a third and final part in the next few days. Please enjoy the video, and I'm sure you will learn a lot on the industrial automation area that has happened in the past in the US. Thank you. How did the market really grow? I mean, okay, it started in the automotive industry, but then, how did it spread it to other industries? Because you were in the sales, probably you were
Right.
exposed more to what the industry was doing and what is the
Right.
need. Other than PLC, let's say drives or, of course, much later DCS
Sure.
came. I mean, the market started developing, I presume, in the US, and you've been all
Right.
part of that. And you've been part of
Right.
Schneider right from the beginning. Therefore,
Right.
obviously, you've been part of that. So I would like you to
So,
go through the industry, the market, how it developed, and grew.
so after the initial start in automotive manufacturing, of course, other people began to hear about this and started thinking of other ideas. Um, for instance, the state of Wisconsin, Milwaukee, Wisconsin, was heavy at that time in manufacturing. And there was another area just across the Wisconsin border in Illinois called Rockford, Illinois, that had a number of companies manufacturing machine tools for the automotive industry. But there were also other industries in Wisconsin manufacturing. So, for instance, one of my other companies that I dealt with, and I was selling them transistorized logic and relays, was a company who was connected to the dairy industry. And they made what were called clean in place systems. These are systems that flush all the piping in a dairy when they change from one product to another, or after a product run to sanitize the pipes with various chemicals, moving the chemicals back and forth and clean out the tanks, all that sort of thing. And they began to hear about PLCs and started thinking about why couldn't we automate the clean in place process? Because before that it was somewhat manual, controlled by relays. You do one thing and then the operator would press a button to do the next, et cetera, et cetera. So that customer of mine, I teamed up with them, introduced them to a very, again, I have to say, crude PLC. And but that's how they got started. And that was fairly typical of how other manufacturers of different products got into it. Now, I have to say, it was mostly machine manufacturers because at that time, those people interested in SCADA took a slightly different direction. So initially, I would say, at least for the first 10 years, you really did not see PLCs in SCADA or process applications to any great degree. Okay. That was being handled differently by different manufacturers. Now, of course, today everything has come together, right? It's all together. It's common. But then it wasn't. It was, you either did one or the other. And I think that was true for Alan Bradley. Was certainly true. Modicon dabbled in process, but mainly they were machine automation, as was Square D. Um, so it just kept growing and growing, and more people adopted it. PLCs became faster and smaller as the electronic components shrank. Of course, everything got smaller, lighter. The microprocessors kept getting faster and faster, which gave it more and more capability. And then along came something called Ethernet. And I don't know what others were doing at the time, but I'm prejudiced, okay? But I think Square D Company was one of the very first companies to look at Ethernet and say, hey, we could connect two PLCs together with this Ethernet stuff. And we did. Now, just as a history uh, item, the problem for Square D was that it had all these other electrical products, and it did not see its way clear to investing enough money in the sales and marketing of automation products. They had very good products. We had wonderful products, well engineered, very smart people, but we just didn't have the sales force that Alan Bradley did, or that the reputation that Modicon had in the automotive business, because they were first on the scene. But we did a lot of wonderful things, including being one of the first to try to connect PLCs with Ethernet. And I remember being shown the first one in the product area at the plant, and I thought, wow, that's a great idea. What is this thing? So, and of course, today, nobody thinks twice about the internet connection, Ethernet, uh, or wireless transmission of data between PLCs. It's all become common. But in those days, we were just learning and evolving. And like everything in technology, it just kept getting faster and faster and more complex, and it just kept growing and growing. So it just evolved from that, and smart engineers looking at new things and saying, oh, you know, nobody's applied that here, but I could grab that and put it in our product. And so that's, it wasn't just us, it was everybody doing it, everybody. And then, of course, a lot of people started making tiny little PLCs, especially the Japanese. I mean, obviously, the Japanese took the lead in miniaturizing the PLC. Very simple ones, but they were much smaller than the American ones. I think in America, people were hesitant to use them at first because they were the Japanese quality, even in the late 70s and 80s, did not have the reputation that it later gained, of course. Okay. But, the Japanese did marvelous things with miniaturization of the PLC, which forced the rest of us to try and do the same thing. So you got to give a lot of credit to the Japanese. You also got to give a lot of credit to the Germans. To me, it's always been interesting, and I never really have, even after all the time I've spent in Europe, understood why. But just differences in engineering philosophy, perhaps, with the Germans and the French and the English. They also developed PLCs. Okay, obviously Siemens jumped in and applied German engineering thinking and techniques, which are different than American. We felt that their way of doing things was overly complex, but the German companies, of course, adopted it very readily. To me, one of the big differences, at least early on, was Americans, for a very long time, stuck with ladder diagram programming. A ladder diagram, I should have remarked earlier, was basically you have your, on a drawing, you have L1 and L2 as straight lines vertically, and then all your relay contacts are done horizontally, to control the machine. You identify what relay goes where and all that. And of course, we just, because that was so popular in the design of relays for machines, it was just seemed like a natural thing for the Americans to pick it up and construct a programming language based on ladder logic. Boolean, very easy to understand. Well, in Europe, uh, Siemens, the people in France, Moulin Mécanique, they tended to go with more graphics and block programming techniques that they developed. And, the US didn't even consider that for, maybe until the late 90s. I don't know what you think, but it seems to me that ladder logic dominated the method of operating the PLC until at least the late 90s. And then finally, everybody woke up and said, hey, there's much better ways to program this thing. And of course, by that time, engineers coming out of college didn't even know what a ladder diagram was. I mean, I think today, if I talk to a smart electrical engineer interested in automation, he would know what I was talking about. They just don't do it. They construct their logic diagrams, they program differently. So, but that was one way that the Europeans were definitely different than the U.S. So,
You've been in this market for many, many years. I would say through the 70s, 80s, and 90s. Where did
right.
the major competition for you come from? Who were the other players who were active in the US? Uh, Even though I would say Siemens in Germany was predominant, and as you rightly said, in
Right,
was Merle-Geron, Alstom, Schneider, these companies were popular.
right.
You went to Japan, you had Yokogawas and Mitsubishis. So when did actually you start seeing really competition from the European companies, and who are the real players here? I mean, whether it's Siemens or
Well, I think from the European side, the main competitor was Siemens, still is. Okay. Uh, Telemecanique and Milan had very little market share in the US ever. Uh, Part of that's because the only way that their products got into the US would have been on a French machine that, the manufacturer of the machine in France chose to use the French PLCs, put them on a machine, shipped them to the US. They got here and, the people that installed the machine looked at it and said, what the hell is this? and, and didn't understand the programming and so forth. And they had to learn a different way to program, which is good because that's why the programming languages started to merge together. And and they did. So it was very interesting to watch this evolution. I've really enjoyed my life and my career in automation, being able to see. I mean, um, some of the explanation I give to people who don't understand manufacturing, I'd say, for example, in a automotive car plant, let's take the example of painting the body of the car. If you look at old pictures, you see people standing there with a spray gun in their hands, no mask on their face, no mask, by spraying the car body. Well, that was laborious, slow. It was very hard to change paint colors, and it was very risky for the painter. I mean, he was breathing in these fumes, great health problems. So with automation today, I mean, it not only has improved the productivity of the factory, but it's lengthened human life and made it much better for the people in the factories. You don't see that anymore. The paint booths are enclosed, they're all automated, it's much safer. Nobody breathes in the fumes or big exhaust systems. But back then, people didn't know any better. They just didn't. And the same is true of welding. If you go back, way back when, to spot welding of the car bodies, so a man stood there. It was usually a man because the welding gun was too heavy for a woman. And even though it was counterbalanced from the ceiling, he stood there with the gun going bump, 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 bump to make the spot welds. And they weren't always regular. There was sparking, there were odors, chemicals coming off from this, and the man was exposed to this. Today, of course, it's all robotic. Okay, I mean, with the advantages of using microprocessors and the advent of robots, the factory life, the people working in a factory have a much better life expectancy. I don't care whether it's paint shops, welding shops, final assembly. All of this automation has led to much better life expectancies for the workers. And that's a factor I don't think people consider enough. And probably it's because you have to live this long to turn around and look behind you to see what happened before and think about what's happening now and how it compares and what it means for human beings.
Absolutely, you're right. And was there any challenges that you felt at that time, going to the marketplace? Because you spent your a lot of time in the sales in the marketplace along with customers. Was there any challenge that you faced with regard to customer resistance in adopting these
Well,
technologies?
yeah,
And
in the first days, it was hard to overcome the momentum of using relays. Uh, Older manufacturing engineers were skeptical. So my first really big automation job took place in about started working on the project in about 1974. One of my customers who no longer exists was called the American Motors Company, which was a manufacturer of cars, headquartered in Kenosha, Wisconsin. And they designed a new car called the Pacer. And this car was kind of small, and it had a huge amount of glass, had excellent visibility. And so with this new car coming up, I happened to be talking to one of their manufacturing engineers one day, and he told me about this project. And I said, "Hey, this sounds like it." He was telling me about the body welding line. I said, "This sounds like a possibility for our new product." And I said, "Why don't you come up to the factory with me next week and we'll demonstrate it?" So we did that. He looked at it. He said, "Yeah, we need to use this." Now, it took us a while to work out how to do it. We had to work with the machine builder was in Rockford, Illinois. We had a good relationship with them. So they had not yet used a PLC, but they were willing to try. And so teaming up together, we worked on the very first body weld line, framing line that was automated. But as I said earlier, the initial PLCs were so huge that you needed cabinets, of course. So instead, what American Motors Engineering did, they built a room. And we put all the processors and all the IOs on the walls, on racks in the rooms. So it was all centralized. It wasn't out by the machines. Now that meant a lot of wiring from the IOs out to the all the sensing devices and push buttons and limit switches and so forth on the line. Huge amount of wiring, but it worked because it was the first time they were doing it. They wanted to have it in one place for troubleshooting, and along with that, we came up with a scheme to build them a desk with a PDP-8 computer, and found a way to allow them to. They had to manually move the connection, but they could access any one of the processors to reprogram it or troubleshoot. So and that was very innovative. Now, after we did all this and it worked, if you go back into the IEEE, you'll find that I am a co-author of a paper that was presented, I forget what year in the 70s, called Keeping Pace with the Pacer. And I was a co-author along with the manufacturing engineer from American Motors and with one of the engineers from Gilman Engineering who made the tooling. So when I go back and once in a while, I pull that paper out and reread it, and I laugh at it. You know, I laugh at what it was, but hey, it worked, and it until they tore the line down and did something else, it continued to work for some years. So but it took a real evolution. Along with the evolution, the other thing I want to talk about a little bit is this comment you had in your earlier questions about the involvement of IT into factory automation. So in the early days, IT had zero involvement. They had no idea that our black boxes were really computers under another name, but very specialized with firmware to do, a very specific task of organizing Boolean algebraic terms to control machines. So IT had no interest, no knowledge, nothing. And that went on for a long time. That lasted, I think, from my background and what I know, until Ethernet came along. And as soon as manufacturing engineering started connecting PLCs with Ethernet, people in IT started to wake up and realize, what are you doing with Ethernet? What are you connecting together? What is that thing? as the processors, just got more and more sophisticated, distributed, everything today is IT. I mean, but originally, when IT first learned about it, in some companies, there was great tension between the operational technology people on the factory floor and the IDE department. I remember I visited a Mercedes factory in Germany that makes one of the Mercedes vans. All of a sudden, I can't remember the name. But anyway, I went in there and I was amazed what the chief engineer for manufacturing was doing, interconnecting our products with Allen Bradley, with computers. He had put Ethernet throughout the production line. He had servers in a room monitoring everything. He could watch everything from his desk. But he frankly said, I don't want IT to know anything about this line. He said, if they do, they'll want to take it over, and they don't know anything about manufacturing engineering, and they'll just mess it up.